Okay, good afternoon, everyone. I think we'll make a start. Connor, if you wouldn't mind telling slides, please.
Killian's going before us.
Okay, just the first agenda slide. Yeah, so thanks everyone for joining us. Yeah, good to be here. Yeah, so my name is Clement Attwood, so I'm Managing Director of Future Energy Associates. We've got Connor Galbraith on the call with us today, as well as colleagues from EnergyTag, Google, and Private Energy Partners. So yeah, just to mind a bit of housekeeping. So the chat will be open throughout the call. We're in webinar mode, so you won't be able to unmute yourselves and speak. But feel free to use the chat, and then we've got a Q&A at the end as well. So if you have questions for that, then please post them in that. Just briefly, the agenda. So we're going to start off with Killian Daly from EnergyTag. So he's going to take us through why we need new systems for hourly tracking of renewable energy. I'm going to give you a bit of background on why we built GranularCertOS and how. But then we're going to have a demo of the platform. We're then going to go to next steps and how you can contribute to the open source projects, and finally the Q&A. So we're going to start off with Killian. So you want to share your slides, Killian?
Sure. Yeah, thanks very much for the introduction. It's good to be here. So I'll just share my screen. There we go. Right. So let me know if you can't see or can't hear me. If not, I will carry on. So thanks for having me here today for the introduction of this open source project on granular certificates. I think it's really fantastic piece of work, and I'm really looking forward to seeing what folks can do with it. I'm just going to run through some quick slides just to remind everyone why we need these hourly tracking systems, kind of where we are today and where we need to go. I'll run through these quite quickly because it's not the point of the webinar. It's really to get into the details is the point of the webinar, but it's important obviously to kind of remember why we do all this stuff. Ultimately, we need a clean electricity system to decarbonize industry and to get to a zero carbon economy. That is the goal of everything we're doing ultimately, right? And that all comes back to clean electricity around the clock. And so we need markets, tracking systems, carbon accounting, all to be working towards that, and not to be, you know, leading us halfway there. We need to get the whole way there. So we need the right incentive system. Today, we don't really get the full picture from the tracking systems that we have. They tend to be monthly or annual. So we can't really tell when green electricity was produced, when we buy an energy attribute certificate, or even when we purchase a PPA, because the tracking systems are quite low granularity. They're not giving us that full picture, and they often tend to be of broad geographical boundaries as well. Obviously, in a granular system, we're getting hourly information. And what does that mean? That, you know, for example, when there's no wind or sun, then we can't use a certificate from 6 hours ago, 6 months ago. We have to find clean energy in the same hour as we're consuming electricity. And so it's really, really important that we change the tracking system so we can change the markets and the incentive systems. And also move towards more locational granularity. These things kind of go hand in hand. That's how power markets work also. So it's not an entirely new concept. This is a kind of a nice illustration of what I've just said, done by folks at Google, just showing, you know, the difference between monthly and hourly tracking. It just gives us a whole pile more information about when and where we really need to be buying clean energy. A monthly picture is not the full picture. An hourly picture is. And that's why having granular certificates, having tools like GranularCertOS is really, really important, right? To accelerate this accessibility of finer granularity information as we get into the next stage of the grid decarbonization story. And again, this is about markets, yeah? So we have this new information, this time-based information about when electricity is produced. And ultimately, what it does is that will help us create clean electricity markets that fill in the gaps when there's not so much wind or sun. So this is a graphic from level 10, energy from the Granular Certificate Trading Alliance, showing that these GCs can really help us identify times of shortage of clean energy and fill in those gaps with clean energy, not with other energy sources. And so that's really, really important. Ultimately, all of this stuff, all these tracking systems and software tools, it's ultimately about making more effective market decisions. And also it's about unlocking cleaner and cheaper power in many parts of the world. So this is an analysis done from the International Energy Agency that came out last Friday. Just thought I'd show it because, you know, there's big financial opportunities from getting to pretty high levels of hourly matching, right? What they find is, you know, especially in Europe and China, very high levels of hourly matching at 80%. It's already cost competitive compared to an alternative of just buying, you know, non-differentiated grey industrial electricity prices. And even in the US, in cases it is as well, the US obviously with kind of lower electricity prices than other parts of the world for industries. This is really, really important as well. We need these tracking systems to unlock the market structures, these solar plus storage plus wind PPAs that need this proper tracking infrastructure. We really, really need to kind of, improve the systems we have today for data management that ultimately can unlock these cleaner and to a large extent cheaper clean electricity deals. This is happening. There's plenty of cases of people doing hourly matching around the world. 30 different organizations. I think we have 4 or 5 continents. That is happening today. You can do it with basically production data for generation and consumption, which is very common data for electricity market purposes. So it's being done, it's being proven, but now we need to move it into GC systems and make it more standardized and scalable. Policy tools are also requiring this in certain cases. European Union's green hydrogen rules require hourly matching by 2030. Same in the US, still at least. And certain state level initiatives like the California retail electricity disclosure regulations are requiring more hourly granular disclosure of electricity origin. And so there are regulatory pushes in this direction also. Also, the rules of the game are changing more globally, right? The set of standards that basically govern how companies buy clean energy, track clean energy, claim clean energy, they're all changing right now, right? The Greenhouse Gas Protocol, carbon accounting rule book really for 90% of companies, it's under review. Time and location matching are one of the leading considerations of Scope 2. The Science Based Target Initiative, they're also reviewing their corporate standards, Scope 2 included. 80% of global market cap has an SBTI target. And again, time and location matching will be a key consideration there. ISO, which is the world's foremost standards body, also reviewing their carbon accounting and net zero standards. So there's a time of change here, and it's important to get the data systems and the markets ready for that change as we move towards more accuracy. Just a couple of quick words on the EnergyTag standard, and I'll pass back over to the guys at FEA. So obviously, I hope I've made it pretty clear why we need more accurate energy tracking, why we need granular certificates to replace monthly and annual certificates over time. So EnergyTag has been working on this for quite a while. We have an open source standard for this, and I'd just like to quickly touch on that because it is kind of the basis for the Granular CertOS open source code base. So basically we have 2 standards. There's the GC scheme standard. So this is all about issuing hourly certificates. It's developed by over 100 organizations involved. A lot of the expertise came from the folks who developed the European tracking standards for guarantees of origin, which is the world's largest standardized EAC system. So a lot of expertise went into that and continued to evolve. And then we have the matching standards. So that's more about how you match those GCs to consumption. There's various roles. I'm not going to go through them all, but basically, right, you have an issuance part that really tracks the generation of clean electricity on an hourly basis. And then you have a set of organizations and tools and processes responsible for matching that to consumption. And then, of course, you have the GC registry, this critical part that's being covered by Granular CertOS, which is responsible for production, trade, and ultimate retirement or cancellation of these hourly certificates. There's also like a developer's toolkit that is there today on the website that will be added to obviously now with the open source code base, API specification, system architecture diagrams. There's a lot in there already for folks who are actually going in and building these systems. And this is, what we're going to discuss today is just another example of tools to aid people's journey to hourly certification. So we have standards. We also have an accreditation process, right? Check them out on our website. Open source. Anyone's free to use them, and reach out also if you want like kind of formal accreditation against those standards. Just finally, a couple of words on this Granular CertOS. I think it's great that we have kind of open source free tool as a way to foster this ecosystem. Anyone, whether it be an existing registry or a new platform, can leverage this work to build a GC registry. I think that's very, very important. This is not the same thing as a full GC registry product, but it can certainly help you get there more quickly and in a way that's in line with EnergyTag standards. It does not mean you're compliant by design. That requires a bit more, but it can certainly help that journey and can serve as a practical tool to making that journey easier. And also, I think it's something really, really important is the work we're doing on the storage module, both our standard and now also as part of this project specifically, is novel and innovative. There's not really a good way yet today that is standardized and scaled of tracking electricity through batteries. We have to solve that problem in clean electricity markets as batteries become more and more important in firming up renewable power. So that's it from me. I hope it's provided a bit of background to why this is important and what the EnergyTag standard is. Now to delve a bit into the how it all works, I'll pass over to Clement Connor. Thanks very much for your time.
Thanks, Killian. Yeah, really good primer there, and kind of leads nicely into what we're going to talk about next, which is just a bit about the motivation for why we built Granular CertOS. So next slide, please. Yeah, so the project really came about from various discussions that were had amongst different people working on the EnergyTag standards. So particularly kind of discussions on some of the more technical aspects and things that is kind of quite hard to talk about in the abstract. So things like, do you want to go for a volume or unit-based issuance? How do you allocate storage to council QCs, which Killian touched on? So one of the primary aims of the project was to provide a real kind of implementation and a test bed for bring some clarity to some of those technical discussions rather than just being able to talk about them in the abstract. In particular, as Killian mentioned, we wanted to help advance some of the thinking on the allocation of certificates to storage devices, tracking the cancelled renewable certificates through a storage allocation and then issuing back certificates on the other side. In all, we kind of wanted the tool to remove some of the uncertainty that might exist in delivering hourly registry systems compared to non-hourly systems, kind of with the overall aim of accelerating granular certificate adoption more generally. So in terms of what we've built and what we haven't built, so the tool is an open source demonstration registry for tracking on an hourly basis renewable energy and storage. It's designed to align with the EnergyTag standards. For people who are familiar, it's configuration 1 system, which means it doesn't interface with any other non-hourly systems for tracking certificates. We made it fairly domain agnostic and kind of a proof of concept, so it's not aimed at being a production-ready platform. As Killian mentioned, it doesn't provide like accreditation to the EnergyTag standard or particularly mapped to any local regulatory requirements, but is designed to be kind of a really good starting point and a tool for people to use to get going. So on some of the kind of design decisions, so as we've developed the registry, we've had to take some specific design decisions. We've had to create an implementation of the registry. We're not claiming that what we've done is the only way to do it, or necessarily the perfect way to do it. But we just wanted to talk through some of the decisions we've taken, which I think may be interesting to people. So one of the main discussion points, I guess, when people think about moving to an hourly system is the representation of certificates on an hourly basis, and concern about being able to track individual certificates through that process. So the design we went for in this case is to have certificates with a face value of 1 watt-hour. Those are all kind of wrapped up periods. So in this case, for every hour of production. Each of those bundles has an issuance ID, which is based on the device and the timestamp that bundle is for. And then individual certificates within that bundle can be identified by the ID ranges within that bundle. So this diagram on the right is an example of how that structure enables some of the key actions on certificates. So in this case, a partial cancellation. So at the top, we have the original bundle, but then getting 75 watt-hours of that original volume cancelled, and 25 watt-hours are going to remain active. So you can see that we have the parent bundle and the 2 child bundles. And just the bundle ranges are changed to enable that splitting. So in terms of the certificate lifecycle management, so this is kind of a slightly dry subject, but it's quite important in terms of maintaining consistency in the registry and avoiding double counting. So once certificates are issued, they persist in the database. Only the lifecycle stages change, so whether they're issued, transferred, or reserved, for example. The status of those certificates is changed in order to change accounts for transfer, for example. And if they need to be removed for any reason, they're flagged with a deletion marker. As I explained in the previous slides, partial transfer and cancellation can occur by creating child bundles for the parent bundle and the parent bundle being wrapped and split. So moving on from that, it's also really important that we have a way of auditing actions as they're performed on certificates. So we can enforce the sequential processing of QC affecting actions. Those all get written to an immutable event stream, which creates a complete audit trail of all the actions that have been performed. And that means that if we want to roll back any of the actions on certificates, that can be done by reconstructing a full history of previous states. So a little bit on the platform architecture. So yeah, before I just wanted to preface this slide actually by saying a lot of the work that went into developing the platform was focused on the back end and the API, and that's really around the kind of top right hand of this diagram. So making sure that the issuance engine for certificates was robust, and being flexible in terms of the integration. So you'll see in this example that we've integrated with the Electron API, which is taking data from Great Britain for devices there. We've made it flexible, so it should be fairly straightforward to integrate other metering systems, should you wish to. And we also have a process for just issuing certificates via kind of a CSD post request to the API. So once we've ingested that metering data, the core of it is the validation and the bundle creation. Those certificates get associated with accounts and devices, and then are available in our backend via the API. The API also enables the kind of key certificate actions that you have for those bundles, and that API is then consumable by the front end. So that's all now operational, and that's been hosted on Google Cloud Compute, and we'll share details of how you can access the platform a little later on. So lastly from me, just wanted to talk through kind of what the user capabilities are that we wanted to enable through the platform. So first off, we wanted users to be able to manage their accounts, register devices, and at a registry level, be able to roll back any actions when necessary. In terms of portfolio visibility, we wanted users to be able to query GCs and view holdings at a kind of gross level, because there's obviously some concern with as we move to like more volume of certificates that it becomes harder to manage. And then lastly, we wanted to enable automation of certificate management through more complex strategy through the API. So I'm just going to hand over to Clement, who's just going to talk you through some of the storage element, which I think I failed to, I neglected to mention on the architecture diagram, but maybe you can cover that as well, Ruthie.
Yeah, not to worry. Thank you, Clem. So that last part on the last slide about creating a platform with programmatic access to enable complex strategies is particularly important, not just for dealing with a world where you have 2 orders of magnitude higher numbers of certificates compared to monthly and yearly certificates. There's a lot of what are currently manual processes that you are just physically not able to do, that benefit from being able to test programmatic strategies and access through the API. That is doubly important for managing storage devices, where you have transference of attributes through time. And part of the purpose of the platform is really to act as a test bed, a foundation for developing what is probably one of the more nascent parts of the EnergyTag standard, and that is the role of the registry in managing the transference of certificate attributes through time, managing charge and discharge records, losses, allocation strategies. So one thing that is being debated at the moment, and I will not go into too much detail on this. We are having quite a bit of debate on this currently in the EnergyTag storage working group. I encourage you to sign up if you haven't already. And there's this idea that maybe the registry doesn't need to perform all of the necessary functions outlined in the standard, such as the implicit monitoring of the state of charge of storage devices, the calculation of the losses, the allocation of charge to discharge records. So this platform is agnostic about whether we follow the path as set out currently in version 2, where it is the registry performing all those things, or whether that role is performed by what we're terming a storage validator, which is a third party that acts on behalf of storage units. It essentially handles all of the more complex elements of the storage tracking and then just provides proof that can be validated by the registry should they need to, in order to cancel GCs and then issue time-shifted SDGCs later in the future. So we are currently continuing to work rather with Google and private energy partners on this. And yeah, watch this space. There's a lot of interesting developments happening here. In terms of getting involved, we are hosting the platform currently on a public repository on GitHub. We chose to go with an Apache 2.0 license for this. The headline on this is you are allowed to use the code within the repository for any public and private purpose, so long as appropriate credit is given to future energy associates that you have done so. And we feel like this is the best approach, given that the whole purpose of this project, of this repository, is to accelerate the transition to granular certificates. And that means helping registries make that transition, overcome the technical hurdles in any way that they can. And to do so, we've taken, for the techies on the call, what's called a domain-driven design. So if you want to get involved, you don't need to spend hours understanding and navigating the code base. You should be able to jump straight in, open a pull request, and we'll be happy to engage with anyone in the GC community who wants to help develop the platform further. So I'm going to give you a quick demo of the platform as it stands. What I will say is the sort of intended use case of this is that you download the repository to your local machine, you spin it up, you tinker with it, you play with it. But in order to sort of break down the barrier to entry for those who may not have the time, may not have the technical skills to do that, but still want to see what a granular registry is capable of, we're hosting an instance on GCP, as Clem alluded to earlier. That is going to be accessible for people who we will be sharing a form to attendees of the call, where you can request an account and we will set you up and you can come in and play with it as you see fits. This is for those of you who are familiar with the EnergyTag API specification that we have been developing alongside EnergyTag now since 2022, 2023. This platform, in a way, constitutes a version 3 of that specification that we'll be updating in due course. But this still acts as the reference it always did, except this time it's actually backed by the backend. So it will enable you to really test the expected behavior of the specification as we've set it out. And we think, based on the feedback that we've had from the community to date on how useful the API specification has been, we think this is a real step change in the help that this is going to bring to the community. So this will be accessible through the GCP instance currently, but like I said, we will endeavor to update the source on EnergyTag very soon. So this is the landing page. And when you request an account, we will provide you with, I'll just sign in as the example user that we've got. There we go. So when you sign in, we have this concept of a user having access to one or more accounts, with the idea that accounts can be subdivided by users within an organization who have access to them, or maybe accounts that bundle particular devices from different jurisdictions that you want to keep separated. So I'll show you account number 1. So this is the interface that we've designed. Now, obviously, when you're dealing with hourly certificates, there's an awful lot of information to process, to keep in mind at once. So what we're still in the process of developing, but have been mindful of, is the filtering and the querying functionality to be able to get to the certificates of interest that you want to see. So what we're looking at here is, within this account, there are just under 4,400 bundles, where each bundle is a variable energy volume within a given hour from a given device. And that is spread over 5 different devices. 4 wind turbines, 1 other device. So if I just move my, yeah, there we go. So the main attributes here that are probably of interest: the issuance ID. So this is assigned to the bundle at the point it's issued, unique to the device, and the timestamp at which the energy was generated. The period the generation started and ended, this is kept variable for cases where the settlement period may not be an hour. There's that flexibility in there to deal with it. And then the volume of energy contained within that bundle. And if we go on to details, these are all of the columns that are mandated as part of the EnergyTag standard to be referenced. when talking about granular certificates. And there's that ID range start and end that Clem demonstrated on his slide earlier, and the quantity within in watt hours. And then some various other administrative details that are important when you're going to be thinking about exporting certificates between registries that may have been issued or cancelled in different legal jurisdictions. So I'll just show you from here. If we go to device management, this is where you can see the devices that are assigned to that account. Now, this is different from the devices I showed you earlier on the certificate view. These are the devices that, when metering data is submitted for them, the certificates issued off of that energy is owned by this account. The devices on the previous screen also included devices from certificates that were generated by devices in another account and then transferred over. So it's important to maintain that distinction. And one of the key things you can do here is direct upload of metering data. I will do this quickly just to show you what this process is. There we are. So that was a very small data file. It only had 4 or 5 hours worth of metering data, but you can see we've got issuance on here for these, and that was for Tiarbo. So if I go back, oops, that's okay. What we've done is we've seeded this database with about half a year to a year's worth of data from Elexon, the UK's ISO provider. So in order to basically give a decent number of certificates to play with, we'll also be updating the certificates daily with a job to make sure that there's always a fresh stream of certificates in here for users to interact with. So if I take now a certificate that is active currently, I will show you what the partial cancellation process that Clem demonstrated earlier. So in fact, what I will do is I'll narrow it down quite a bit more to make sure that we can actually see the effect of it. So let's do this. There we go, that's better. So, and I'll make sure we get an active one as well. There we are, so this is the top line one. And if I move my screen out of the way, yeah, 6 pages down there. So we have the option here to cancel, or rather perform an action on the bundle. This includes transfers, reservations, etc., based on a percentage of the bundle itself or a quantity of energy. So I'll do a percentage for now, be the beneficiary blank, cancel that. And there we go. We can see we've halved the number of certificates in that bundle that are remaining active. And then if I go cancelled, we'll be able to find the other half there that has now been cancelled. So one last thing I'll show you is transferring a certificate to another account. So that remaining 2.7 megawatt hours we've got, let's transfer half of that again to the other account that we have set up on the system. When you request access to the platform, what we will do is create a fresh, clean account for you that only you will have access to. And we will also give you access to this central test account containing all of the Elexon issued certificates so that you can experiment with transferring them between the two. There we are. So 1.366 left, eMark 1. If I now go down here and switch the account to the account that just received. Yeah, there's a fair few on this one. There it is, 1366, sent by the other accounts. So yeah, that's an overview of where we're at currently. We are actively working on the storage component on the back end. We're about 70 to 80% through on that, on the dev branch. And then we are going to extend the front end to be able to interface with that storage functionality. As Killian alluded to earlier, given the novelty and the added complexity of working with storage data, we're still definitely in the process of working out what the best UX for that would be, given how many more variables and dimensions are involved compared to the granular certificates themselves. So we're definitely looking to get thoughts, feedback, debate on that. So I'll return us back to the slides and pass back over to Clem to talk about the next steps.
Yeah, thanks, Connor. So I think that, yeah, then that leads in nicely. So yeah, as Connor mentioned, we're going to work on the storage element of the registry. The main point in particular that we're working on is developing integrations with a third-party validator and allocation party of storage. So what that means is, rather than the registry itself doing the allocation of charge to discharge records within the registry, a third party would do that, and the registry would integrate with that third party to then issue granular certificates off the back of it. So that's kind of what we're working on at the moment, and that would require probably some other changes in terms of moving to a different configuration of the registry as well, potentially to work with existing non-hourly systems as well. We're also looking for kind of other opportunities to pilot the registry on more domain-specific versions. So we've obviously used Electron data, which is real GB data, but it doesn't necessarily correspond to what the manager of registry would want to use it for. So we're actually looking for people to take it on and use it for that purpose. And more generally, we really kind of build on what Connor said. We want to work with the community that are involved in developing hourly systems to make further enhancements to it. People have already left some feedback in the form of issues on the code base, so welcome any further contributions along those lines. If you want to create an issue, suggest a fix, we'll open a PR and merge that. Yeah, I think that's it really. More engagement and feedback is the point of that. So that brings us to the Q&A. I think we've had a couple in the Q&A panel. So I think we've got a couple that have been answered in line. So we've got one from Devon on: is the goal of the software to be used by buyers, sellers, LSEs? What all are the different use cases? So I guess we're not being prescriptive about who this is for, I suppose. The aim is generally to enable faster adoption of hourly registry systems. So if registries find that useful in terms of getting a head start, or registry operators to build hourly systems, then that's great. If it's buyers and sellers, then that's also good. But I think primarily it's probably more focused on registry, but welcome.
Yeah. Well, obviously, maybe I can pop in there because it's a really good question. I think, as you mentioned, Clem, probably the main folks this will help is registries or people looking to do energy tracking. Obviously, buyers and suppliers could benefit from that, right? But ultimately, you know, for example, in the EnergyTag standard and the way EAC systems are structured today, it's usually almost always a third-party entity, right, who's responsible for doing the energy tracking to make sure that the buyers and sellers on the market are independent from the tracking system. So ultimately, I think it's probably mainly focused on registries. It's also maybe just kind of quick comment. We shared the GitHub link. Thanks as well, Nicholas, for sharing the Energy Track and Trace project, which is another great example of an hourly tracking system. One thing I forgot to mention also, just stay tuned in the next, probably in the next 3-4 weeks, we'll also have announcements of the first couple of EnergyTag compliant GC schemes. So yeah, stay tuned for that. We'll have another webinar probably in 4 to 6 weeks probably to give more details on that. So there's plenty coming down the road here.
One thing to add from the Google side as well. Hi, everyone. Hallie Creo from Google. I wanted to add a note on why Google was supportive of this project. And it does relate back to the development of tools for registry operators. We had seen that there had been a number of pilots, but that it hadn't really been taken to the next stage of what does it mean to be that configuration one, and what does that look like, and how does that technically work? And we wanted to build on top of the API standard and put it into practice and implementation as an example for registry operators as a tool to help implementation further down the line, but also acknowledging, as Clem did up front, that we know that there are going to be registry specific, issuing body specific elements that are not captured in this tool, and this is meant to be a starting point and something that can just help move things along and reduce costs for taking those next steps.
Okay. Yeah, so for the question, is the end goal of global public registry or more a tool for individual buyers or sellers? So I think we've probably covered that in terms of kind of the goals of the project. It's not to become a production registry that has specific users at this point. It's more a tool to kind of speed up development for other developers of registries. Question from Caroline: does this allow different entities to transfer GCs between themselves or only between their own accounts? Kind of generating facility register for it, or for this, if it is also signed up to a non-granular registry, or does it have to choose? So this isn't a live implementation, so the functionality is there to have different trading accounts on the platform. So you can transfer GCs from a generating account to a trading account, as in a similar fashion to like Connor demonstrated the cancellation. It's a configuration one setup, so it's kind of a standalone registry, so it doesn't interface with a third-party registry. It's kind of a standalone configuration one if you're familiar with the EnergyTag standard. Question on what makes storage difficult to deal with when trying to create hourly systems. I'll say that one. So I guess there's all sorts of complicated things with storage. I suppose one of the hardest bit probably is maybe hand over to Killian, who's got his hand up, is allocating the discharge record from the charge record. So obviously you put some energy into storage and you only get a certain fraction of that back out. So at some point you have to decide which of the incoming energy you are getting back out of that storage device and which of those you allocate to the renewable certificates that are going into it. But Killian, do you want to jump in on that one?
Yeah, sure. There's just a couple of comments as well on some of the other questions. I think, you know, about is the end goal a global public registry? That absolutely not. You know, there's already legal frameworks in place in places like Europe that, you know, have regulatory requirements around issuing bodies per European country. So for, you know, governance, technical, and various other reasons, I don't think having a global public registry is desirable or realistic. This is obviously a code base that people can use, whether they be in Europe or Asia or the US or wherever else, to start the GC journey, and as Hallie mentioned, to lower costs in doing so, and to help people to do that in a similar fashion, right? So we have kind of harmonization, standardization of systems. The other thing, just quickly on storage, that is something quite novel. Essentially, you know, you can't value the benefit of energy storage without hourly tracking, right? If you have a monthly tracking system, it's totally unable to say, well, the energy was charged in at 6 p.m. just before the sun went down, and then it just charged at 10 p.m. So that's a problem we have to crack. We do have a framework for that in the EnergyTag standard, and then implementing that in terms of code. There's a kind of a few design choices to be made there, but that is a nut we have to crack. Today, clean energy markets essentially provide no value to storage in almost all cases, and that's something that we obviously have to change. And so we're always very happy to talk to folks who'd like to help us, you know, answer some of the questions we have on implementing storage. We're doing a storage working group at the moment in EnergyTag, so reach out if you have, you know, specific ideas on hourly tracking for storage.
I think just to add on the kind of difficulties with storage as well, it brings in a requirement for a whole other set of data. So it likely requires that you have to have the storage charge and discharge records alongside your QCs. You probably also need to have efficiency measures, or you have to have state of charge records, and that all brings in new requirements that, and whereas some domains are already struggling to build hourly systems, let alone bring in storage data requirements on top of that, and have new processes for doing that allocation that I mentioned. What is the underlying technology? It's not blockchain. It's built on Python backends. Don't know. Can go into more detail on the technology. I don't know if you have a more specific question on the technology part.
I think our use of the word ledger was quite specific in that it is an immutable event store rather than a chain with a Merkle tree and encryption and all of that stuff that happens on the blockchain side. It's designed to use tried and tested technology as a way to reduce the friction and the barriers to entry for what might be registries that are used to more legacy technology. And speaking of technology as well, Alex in the chat asked about performance since data will be in the 100 million record per month. I think it's going to be quite a few less records than that. There's only about 720 hours in a month, and even with 10,000 devices attached to a registry, you're still then only in the region of, you know, 1 million, 5 million actual issued certificates per month. That is for enterprise level data management systems, very, very small. And again, each row that we showed, each bundle is on the order of, you know, 0.5 kilobyte at most of information. So we've done the maths. We will probably end up sharing it later on as part of one of the working groups. But the actual data volumes and the data velocities that you're going to be dealing with here, even if all devices in the US were to transition to using granular certificates, is, you know, you're talking USB stick levels per month of data. It's very minimal.
Yeah, maybe just to chime in on that one as well. I think, you know, that is the question that we've had as well in the European context, and yeah, like the data volumes are really, you know, I've talked to some friends, you know, who work in tech, and they kind of laughed when I asked them, is this going to be a big data problem? Like, absolutely not. We're dealing with way larger data sets in the world today. Something like Netflix streaming is orders of magnitude, millions of times more data. I think we did a back of the envelope a few years ago. I have to maybe double check it, but there's about the same amount of data as an autonomous or 2 autonomous vehicles would produce in a year to track all of the meter data in Europe, if it were to be hourly. So we're really like, you know, not in a big data space compared to some other you know, tech applications that we have today. Maybe we should do a little post on that, Connor, because that is kind of one that kind of comes back a bit.
Connor, you want to take this next one?
The user interface question. Yeah, indeed. So there were two motivations for this in our engagement with current registries. There's an element of not wanting to make the transition for existing users of EAC registries to taxing for them. So taking design cues and UX cues from interfaces that they are already used to in the GEC registry compared to what they're already used to. If that is as quite an easy way, a low-hanging fruit of convincing them that actually the transition isn't as scary as you think, the table is just a bit bigger. Again, I think it's worth stressing, in a real production environment, you, as a user, as a owner of a portfolio of devices, you're very unlikely to be clicking through these tables manually, you know, doing multi-select and clicking transfer. You are much more likely to be doing this through an API programmatically through a tech team with a strategy. So that is sort of the intended use case of interfacing with these certificates, and that's what we've been saying since writing the API spec a couple of years back. The UI is mainly just trying to think of the right word. I don't want to say like point of comfort, but just like a point of assurance that you can actually see what's happening still. And that borrows a lot of the design cues from existing registries for sure.
Yeah, just to kind of add to that briefly as well. So yeah, we in the back end, we have also created some functionality to perform things like recurring actions for certificates. So if you're the owner of a particular device and you want to always transfer certificates for that device to a particular trading account, for example, then yeah, thinking about building those helper functions to enable people to manage certificates in a more sensible way rather than having to log into a portal every week to get through and only transfer stuff. So another question from Katrine. If a registry operator wants to offer the producer the choice between monthly or hourly certificates for their production, what additional retention points are to be kept in mind for the registry design? Does it simplify by limiting the total number of granular certificates to only those who seek it, or complexify with evaluating additional measures to prevent confusion? So we've done a little bit of thinking on this, but I think probably other people have done more on this because the system that's designed is supposed to be a config one, but it's already an hourly system. So we weren't setting out to design a system that would enable people to transfer from non-hourly to hourly. Having said that, I think there's some fairly practical things that you can do to enable that transfer by kind of if you have a cohort of customers who are keen to pilot hourly, then there's ways of setting up the back end where you can fairly easily transfer accounts between a non-hourly and hourly system and have that managed. It's probably quite trivial to say that on the call and maybe quite a lot harder to do it in reality, but people are starting to work on it, and there's definitely practical solutions to that. It's not something we've engaged with like end users on in a lot of detail because it wasn't kind of focus of the project, but hopefully that gives some flavor on that. Question from
just to iterate a little bit on that, Clem. I wanted just to remind everyone, this is this was built more as a guideline. So some of these questions I know people are asking, looking potentially for answers, and I think a lot of those answers are going to be answered. One of those questions are going to be answered when registries start to implement their solutions. So I don't think there's one right answer or wrong answer to a lot of these things. It's going to be how each of the registries adopt the code base that Clem and Connor and their teams have worked on. So really just to, some of these questions are certainly difficult questions to answer. I don't think we're going to be able to answer them on this call, but I do think that this is a monumental step forward in providing sort of the framework for granular certificates, and then hopefully we can continue these conversations and have more clarity on some of the answers going forward.
Right, well, yeah, I think that's good reminder. Probably one for Killian or Yoganta. What's the best way to join the working groups? What pieces do you currently need the most support on?
Yeah, so we'll send a follow-up mail. Yevgeny will send that in the coming days. So just reply to that, and we can have a discussion about what particular aspect you'd like to bring there. At the moment, the main things that we're working on, and so really looking for folks with like a lot of knowledge on storage device operations. It's like, for example, how do you properly calculate the losses associated with storage, and then how do you design an effective allocation methodology, basically decide to kind of decide what leaves the battery when you're discharging, what attributes leave when, right? Like they're the two main questions that we have to resolve, and I think they are the two main questions of doing battery storage. Everything else is pretty pretty much agreed, I think, between the groups. So they're the two main ones, but just respond to the mail from Yevgeny and we can set up a call to chat about it more.
Another question on accreditation in the chat as well. Is the accreditation program live? Which organizations get accredited?
Yeah, the accreditation it is live. So just go to the EnergyTag website and just go to the accreditation section. It's all explained there. If you're interested, reach out. As I mentioned, we'll have 2 accredited entities being announced in the coming weeks. Obviously, it's a voluntary standard. We can't force you to get accredited, but we think, following standards and norms and offering a higher quality product because of that is something beneficial to the market. And so, yeah, obviously that's why we'd encourage you to get accredited, but that's really your choice.
Okay, so I think probably pretty much out of time. I think we can just put the last slide up on it. This time to say thank you for everyone for joining. Yeah, please get in touch. We'll be sending around details of how you can get involved. And again, thank you to Google Private Energy Partners and EnergyTag for supporting the project. Yeah, you've done it without your input. So.
Yeah, thanks very much for having us along and as well.
All right, thanks everyone.